Hi, everyone. It's Judy Warner. Welcome back to the On Track podcast. Today on the podcast, we have one of your favorites, who is Rick Hartley, the principal engineer of RH Enterprises. And Rick has agreed to be one of our speakers at this year's virtual edition of Altium Live 2020 in October. Rick and I are going to talk about what he's going to teach you, and we're going to give you a link so you can join us later this year in October. So lean in, enjoy. I'll see you on the other side. Welcome to Altium's On Track podcast, where we talk to leaders about PCB design, tackling subjects ranging from schematic capture all the way to the manufacturing floor. I'm your host, Judy Warner. Please listen in every week and subscribe on iTunes, Stitcher, and all your favorite podcast apps. And be sure to check out the show notes at altium.com/podcast, where you can find great resources and multiple ways to connect with us on social media. Well, hi, Rick. Thanks again for joining. It's always a joy to have you on the podcast.
Hello, Judy. It's good to be here. It's always a pleasure to be with you.
Thank you. Well, Rick, I wanted to share you with our audience, and delighted to know that you're willing to come once again. When we get feedback on Altium Live, everyone always says, bring back Rick Hartley and Eric Bogatin year after year. And so we're delighted to have you again. So why don't you, for those who may not be familiar with you, Rick, why don't you just give a real brief overview?
Hi, sure. I'm Rick Hartley, as she said. Been around the electronics world since 1965. I've spent early years as a technician and field service guy, became a double E, and about 12 years in, decided to get into circuit board design as well. And after a short time of that, made a on purpose decision to become a full-time board designer. And I have been such for about the last 42 or 3 years. I still get involved in circuit engineering, but my main job now is circuit board design. And over the years, I've learned a lot about what you have to do with circuit board design to make them work, to pass EMI, to minimize costs. All of those things are just things that you pick up after you've been beating your head against the wall for 40 some years, as I have. And so that's a little about my background.
So here's one of my favorite fun facts about Rick Hartley. Rick, how many books have you read about
over 120. Over 120. I started buying books in the 80s when we first started having problems with circuit boards. It was because rise times were getting fast enough that things were speeding up to the point where issues were beginning to happen. And I don't think I knew anyone who understood why. Truth is, I didn't. And so I bought Henry Ott's first book, the one that he published in 76. The title of it escapes me at the moment. But anyway, I bought that book first. And then I started buying other books just to try to figure out what's going on here. Why are we seeing interference issues? Why are things not working as they should? And between 85, 6, 7 time frame and the early 90s, I bought probably 6 or 8, 10 books. In 93, I figured out I really need to get serious about this. And I started buying books at a pace where now I own somewhere between 120 to 130 books. I've spent about $20,000 on books. And I'll tell you what, it's been worth every penny. It's the knowledge I've picked up from those is immense.
One of these days, I'm going to hit you up for your book list.
Oh, boy.
So I can share, or your favorites, like Rick Hartley's top 10.
I have a list of 12 that I share with every workshop I do.
Okay. I want that list. Like, let's put it in the show notes or something.
Sure,
because
happy to do that. That's a good idea.
Okay. I'm glad I asked. So Rick, tell us about, you're going to be doing an hour, sort of a keynote live presentation at Altium Live, I believe on October 8th. October 6th through 8th, for those who are listening, is our Altium Live Virtual Summit. It'll be 3 half days with live sessions, and then we will also have some afternoon and on-demand sessions. And by the time this podcast goes live, we should have that new website up and you can go register. So, Rick, the topic, I sort of left it up to you, like what's something that's of interest to you that you're passionate about, something you're observing, in the real world that is problematic. And both you and our own Ben Jordan landed on the same topic. So I assume that was a gold mine. So why don't you talk about that topic that you're going to cover, and also why you think it's so relevant today?
Happy to. The topic basically is designing for cost. Designing to minimize cost, obviously, is the intent of that statement. I've noticed over the years, and I was one of these people once, when I pick on people for not understanding the problem, trust me, I understand this because I once didn't. I remember being the fool that got picked on because I didn't have a clue what I was doing. And I'm going to basically talk about a couple of areas. One, bareboard design so that they are easily producible, so fabrication goes smoothly, so costs are minimized. I'm going to talk about a couple of areas to do with bareboard fab, and I'm going to talk about a couple of areas to do with assembly, things that people can do in the design to make the assembly go smoother. An example of bareboard fab that I'm going to talk about is sizing the board for maximum producibility to create an absolute minimum cost. And a perfect example of that came up in 1990 when I went to work for Goodrich Aerospace. First day on the job, my boss took me around to all the departments and introduced me to everybody. And the second day, I sat down with the mechanical engineer who was designing a packaging structure for a brand new tactical collision avoidance system, otherwise known as TCAS. Those of you who fly know exactly what TCAS is. It's mandated in most parts of the world now and has been in North America for a long time. The idea is that each pilot can see where other planes are in their vicinity, so they can, quote unquote, avoid them, hence tactical collision avoidance. And so I sat down with a mechanical guy and we're going over the packaging and the concepts. And he started talking. He said, "You're going to be designing the boards, right?" And I said, "Yes, I am. And I'll be working with the engineers on some of the circuits." And he said, "Great." And I noticed the board, something looked a little odd. And I said to him, "I'm curious, based on what I'm seeing with the packaging, what size are these boards?" And he went, "Oh, I'm glad you asked that, Rick." He said, "I found out recently that fabricators produce boards not one at a time, but they produce them in panels." And I said, "That's right. That's exactly right." And he said, "Yeah, I learned that." And he said, "What I also learned is that they all have different size panels they produce, but everybody literally worldwide produces an 18 by 24. That's just the size that everyone will produce." And I said, "That is also correct." And he said, "Based on that, I thought, why not maximize material usage?" And I made the boards 6 by 12. And I said, "Ooh, you're thinking in terms of sheet metal, aren't you?" And he said, "Yes, I was." He said, "I wanted to divide that 18 by 24 into X number of perfect circuit boards." And I said, "That's great. And I applaud you for your effort because," and I meant it too, I was serious. But I said, "There's more to it than that." Unfortunately, the bareboard fabricator needs some of that panel space to be able to put in what's called thief copper around the edge of the panel. They need tooling area. They need area for coupons, and boards where we're going to have controlled impedance. They're going to need impedance coupons. They'll need microsectioning coupons to look at hole plating and a whole host of other things. And unfortunately, you don't get the whole 18 by 24 area. And he said, "So what do we get?" And I said, "Well, it depends on the fabricator." But I said, "Let me check with purchasing, find out who we buy boards from. I'll contact them and I'll figure out which of our fabricators needs the most of the panel. And with what's left, I'll figure out a board size that'll fit nicely." And he said, "Great." So I went away, did my work, came back, and I went to him and I said, "Turns out we're relatively lucky. We can reduce the board by 3/4 of an inch in both dimensions, from 6 to 5 1/4, and from 12 down to 11 1/4. And we'll be able to double the number of boards that we put in a panel." He went, "Really?" And I said, "Yep." And I showed him on the whiteboard why this all works out. He went, "Wow, that's great." He said, "Will it have the cost?" And I said, "Exactly, it'll have the cost." So the next day we went to a meeting. One of the things that happened when I first started, a couple of people warned me about an engineer named Bill. Bill was basically pushy, to say the least. And he was one of the people in the world who believes that he knows everything and that everybody else is an idiot and you can't tell him anything, right? I'm not trying to be rude, but this was what Bill was like. He was just one of those guys. So go to the meeting, and turns out Bill's in the meeting. And Wade's explaining to management. You know, Rick and I were talking, and he showed me I was a little off on my understanding of boards. Here's what we need to do to minimize cost. And everybody's like, wow, well, that's not that much smaller. We should be able to fit. Yeah, it'll work fine. How much are we going to save? And Wade said, the cost of the boards will cut in half. And Bill said, what? He looked at Wade, he said, what do you mean cut in half? Luke, take 3/4 of an inch off and the board cuts in half? Who told you that? And he said, well, I just told you. Rick said it. He turned and looked at me and he said, you're a GD liar. And I thought, okay. Now what do I do with this? I mean, this is like my 3rd or 4th day on the job, you know? And I'm thinking to myself, should I react or should I just be pleasant? And I didn't. I mean, this guy really rubbed me the wrong way instantly. So I decided to react. I was like, you know, jobs come, they're not that hard to get. I mean, there were other people talking to me at the same time. If I lose my job, so what? And I said, Bill, I hate to be rude, but I'm not a liar. But my friend, you are an idiot. And oh my God, boy, did he hit the roof. Oy. And so fortunately, cooler heads prevailed and management stepped in and said, hey, guys, come on, you know, explain, Rick, why this is true. So I explained to them how just taking 3/4 of an inch off each side would have the cost of the board. Once they understood it, they were fine. As far as Bill went, he was so embarrassed by the fact that he was wrong, he got up and left the meeting. For 6 straight months, I would pass him in the hall and I'd say, hi, Bill, and he wouldn't even talk to me. 6 months. It's amazing.
That's what you get for being right. And well, I think it's right. Important to notice, like, that this still happens today. This is not a problem from the 90s.
Oh, I know.
This still happens. And in fact, Kelly Dack came on and talked about, you know, proper spacing on panels, and people ate that up. Like, it's amazing. You and I've talked about this a million times, that not only are the problems the same, in some case they're worsened because at least you had direct access to your board shop. But if you're buying, say, through an EMS company and you're outsourcing the purchasing of boards through them, there's often that disconnect.
Right.
You know, and so anyways, I'm excited. What other topics? So that's a good one, you know, optimizing a panel for cost. What other subjects might you touch on?
Well, as far as bare boards go, one of the other ones I'm going to touch on is copper balance. This is something that I learned the hard way when I was young too. It's extremely important. A lot of people will just lay out their circuit board and put the copper where it happens to fall based on where components are. And then when the board shop realizes they can't produce the board effectively because they can't plate things properly on the outer layers because the copper isn't evenly distributed, they'll call them up and say, hey, can we add a thief copper to the surface, you know, copper dots, or can we add, if the board doesn't have a z-axis balance, they'll ask, can we put a blank plane inside the board? I've had a couple of fabricators recently tell me they do that to some of their military customers' boards because they can't produce them otherwise without adding these planes. The problem with all of that is when you put copper in a board that's not connected to something, there will be energy that will reference that plane. And as it references that plane, it will produce electron movement in that copper, and it will not have a path back to where it came from. And that is a big, big problem. And so the bottom line is, I'm going to talk about how to go about balancing board coppers so that the fabricator doesn't have to. I'm not suggesting that the fabricators are right. There has to be balanced copper or they can't produce the board properly. But it's up to the designer to make sure they do the job so that the fabricator doesn't have to, because when they do it, they're just going to randomly add copper where they need to balance it. And that is not a good thing to do to a circuit board because it will impact performance and it will impact EMI. So you shouldn't go there.
Well,
That's
and it's
another
like,
topic.
again, there is one of those instances of the disconnect,
Yeah,
right? Is that a board house could call an engineer and saying, hey, we have to do this
right,
for the plating tanks to work correctly.
right,
And you're right,
yeah,
we do, or it'll be unbalanced and it'll make a mess.
right,
And engineer will go, okay. And then, we, as a fabricator, will build it. We're saying IPC spec. Here's where Joe engineer signed the thing saying we could add the thieving, gets back. He's already, he or she's already, simulated performance and then gets it in and say, this thing's a hot mess. It's not working.
right,
Why?
yes,
And then if you don't have a deep understanding of EMI, it's a rabbit chase. You don't know it.
yeah.
So
And
it
there's a
create,
condition that's even worse. When someone tells the fabricator, no, you can't put thief copper on the board because it may affect performance, especially let's say it's a sensitive analog board. Okay.
right.
So what do they have to do? Well, they have to put thief copper outside of the board area because they have to balance the plating one way or another. So they're forced to put the copper outside the board area, which guess what? Means they're going to get fewer boards on the panel. And guess what? The cost is going to go up. I mean, all of these things play together.
I know, play together. Oh my goodness. It's
I know. Isn't it crazy?
It's crazy. And again, there's a lot of reasons why this happens. And,
Yep.
Even you and I, for having been, in this for so long, we always say, talk to your fabricator, but it's not always possible, or at least not easily, because so much work is done directly through EMS companies and they have the direct access to the designers, but you get in this triangle, right? And there's a reason for that. And,
I know there are reasons for that. When I was with L3, one of the things we did was control who the fabricators were. And we did that for quality. We didn't do it for cost. We did it for quality because we had some fabricators selected by the EMS people where they went purely for cost. That was their game. And some of the quality of the boards we got in were a problem and they were failing. So we ended up controlling the fabricators and simply told EMS, you just need to buy from these fabricators. And they said, that's fine, but they're more expensive, which means we're going to have to raise our price to you guys. And our management said, hey, look, if it improves quality, no problem. The companies have to understand it's a give and take.
Yeah, and I think that's a good point. And I think that's actually good advice to offer, Rick, is that whenever you can, you pick your fabricator.
Absolutely.
There's a lot of very capable EMS that have design services up front, and then there's continuity and communication and all of that.
Right.
But if you are using EMS and you're able to, I would pick your manufacturer and not hand off the ownership of them choosing. I think, no given EMS companies, they want to succeed too. It's not always they're going to pick the cheapest one that's lowest quality or whatever. A lot of times they do pick good ones, but you just lose that level of control and that level of communication. So I think if you could stay in the loop of your own fabricator, that would be really good advice. Okay. I know you're going to talk about many, many things during your talk, Rick. Do you have one more thought to share with us just to give them a taste of what you'll be covering?
Yes, the impact that footprints have on the ability to assemble. Everybody knows that footprints are important. I think everyone knows that. There are some footprints that work well, and some of them ones recommended by IC companies, for example, for their own ICs that aren't as solderable as they should be. Let's just leave it at that for now. I won't mention any names, but there are some that just could be better. And a good piece of advice would be to use something like the PCB Libraries footprints because they're synced with the IPC standards, and an enormous amount of effort went into those IPC standards to make them what they are. They weren't some willy-nilly choice where somebody said, oh, I don't know, let's try this. They had a lot of effort that went into selecting those footprints. And so that would be one recommendation. But there are certainly ways to do that and not to do that. And that's something I'll talk about as well.
Well, I'm really excited for you to teach about this again, to avoid pitfalls. And I don't think that, people like you've already taken all the hard knocks. So instead of each design engineer going through that same learning curve one at a time, I'm very happy to be part of putting people like you, Rick, with all your years of experience in front of our audience, and hopefully helping them skip some of that pain along the way.
Yes, indeed.
And it's amazing that all these years later, they're knocking their head on those same walls. It's amazing to me.
Things stay as they are. They don't really change over time.
Which is silly to me.
Engineers have a lot to learn. You know that. And board designers, whether they're double E's or not, have a lot to learn. It is an intense field.
And getting more intense by the year.
It is. It's getting more and more intense. And so for people to even think early in their career that these things matter, they might never enter their mind that I need to care about this stuff. And that's why I want to try to enlighten them, especially some of the newer folks, the younger, newer folks. I want to enlighten them before they stub their toe.
Yeah, exactly. Well, I also want to thank you for our listening audience. I formed a sort of group this year in preparing for Altium Live, since it is a virtual event and I had the ability to do so. I assembled sort of a dream team of Altium users, supply chain folks, and then, subject matter experts like Rick, and I put them all together and I said, you guys tell us how to do Altium Live. Where are the pain points? What's hard? And Rick has been part of that. So I really appreciate Rick has spent a bit of time with me on the phone, saying this, not that, tune this, move this over here. So I really appreciate your investment in sort of guiding.
The group you have is spectacular.
It is a spectacular group. It is a spectacular group. We have, supply chain experts. We have industry iconic people. We have a guy in there that's only been laying out boards for 2 years. It really covers the gamut, but what I like about it is that you guys and gals all get to rub shoulders with each other. But my favorite thing is we always had this vision of, our users and the industry owning this conference, and that we facilitate it, but you really tell us, what hurts and how to fix it. Right. So it's been such a joy to work with y'all. So we thank you for that. And another thing you and I share in common, Rick, that I want you to talk a minute about, if you wouldn't mind, is both of us sit on a board for a newly formed design. It's called Printed Circuit Engineering Association. Right. It's an association made to bring designers together with supply chain and the whole industry, right, to help them grow, to meet personally or virtually, to get resources. So I know you and I are excited about that. So why don't you tell us a little bit about that? And then I'm going to share a link below so people can join.
Good idea. Thank you. PCEA, Printed Circuit Engineering Association, was actually born out of the IPC Designer Council. The Designer Council existed for many years, from the early 90s until not terribly long ago. IPC, and for many reasons, this is not a shot, they just decided to distance themselves from the Designer Council. And the board of directors that had reported to IPC for years, Judy, myself, Mike Creed, and Gary Ferrari, and others, Steph Chavez, and so on, all decided that we needed to keep this going. There were chapters in existence, there were chapters forming for the Designer Council, and there was a lot of knowledge that we could disseminate through the PCEA. And that's really the key ingredient, is being able to help people learn what they need to know and figure out where to find what they need to know. So we decided to form the PCEA in order to keep the concept in motion. And that's really what PCEA is. And as you pointed out, we're working with a lot of people. We have people in the ranks from fab houses like Jerry Partita. Is it Partita or Pardita? Partita.
Partita. Mm-hmm.
I thought so. I thought it was, but I wasn't certain. People like him and people from assembly houses. I mean, we have people from all stations in the printed circuit industry, and we're going to continue to bring people like that in. There are new chapters forming all the time. Where I live in Central Ohio, we're forming a new chapter as we speak. So there's a lot going on, and there will be a lot going on in the future.
So very much in line with the conversation Rick and I have had about, learning from the pros and rubbing shoulders with other, much like the Altium Live advisory group, right? Is that I think the more time that you guys spend together, I think everybody gets better, right? And so I'm going to share that link below. You guys can go. It's free to join. However, it's self-supporting. So there's a recommendation that you pay $25 just to support the admin fees and the website and things like that. So I'll put the link in the show notes below, and I encourage you to go over and join. And there's lots of action. Sometimes we did a grand opening and Rick did a talk. I think that might be available on the website now. So I encourage you to join that. And then Rick, the last thing I wanted for you to share with people is upcoming PCB West. I understand you're giving something like 6 talks at PCB West, which is also virtual this year. It
is also virtual this year. You can just go to pcbwest.com and you'll find information of how to sign up for those of you who haven't received a sign up email. They're usually during the conference, it's live. And if you go and it's 3 or 4 days, you may be able to take anywhere from 20 to 30 hours of training if you go all day, every day to something. They're going to offer through this virtual conference 130 hours of recorded training that you can watch, some of it during the week of the conference. Anything you want that's there can be watched during the conference. And up to a month afterwards, you can watch any of the recorded events from the conference for the cost of the conference. It's $8.95 to partake. And that seems like a lot on the surface, but I'll tell you, when you think about 130 hours of training from Lee Ritchie, myself, Eric Bogatin, Dan Beeker, Gary Ferrari, I mean, the list, Susie Webb, the list goes on and on and on of excellent trainers. And what you can get out of that is huge. It's huge.
Yeah, it's absolutely huge. And last year, I think you and I were talking about this, and Jeremy Blum, who was right in the Bay Area, was a young, up and coming superstar, really ended up going to PCB West for the first time. I think what's exciting this year for our listeners is, depending on where you are, you don't have to travel or get a hotel or ask your boss for time off. All you have to say is, I'm going to get access to 130 hours of training, that I neither am going to consume live or afterwards. And I think, isn't Mike Buteau and UP Media, don't they offer certificates too, so you can put this towards your CE credits?
They do. They offer, some of the classes have certificates, not everything, but some of them do. And there are several certificate programs in the conference this year. That's mentioned online when you go to pcbwest.com, and you can tell which classes do carry certification and so on. Yeah, absolutely.
Well, hopefully to our listeners, we've given you lots to think about. Again, we encourage you to join us at Altium Live October 6th through 8th in North America. And as I said, the website should be live by the time we publish this. And please go. It's free, which is fantastic. And
it's a really good price,
It's a great price. You've never had such a price. So we're really excited to offer for free. And we're really excited, again, that people don't need to travel and book hotels and get sign off from their bosses. And, there's many people that have said, oh, only 1 or 2 people can come from our team. And now our whole team can join. So we are going to make it so fun. It's not going to be boring webinars. We'll have wonderful people like Rick speaking. We'll have virtual happy hours and some kind of design contest. And we're going to try to make it really fun and not just boring
It
webinars
should be
all
great.
day.
I mean, there's also Eric Bogatin, if I remember correctly.
Eric, it will be speaking. We're really excited to have Eric.
Steve Sandler.
Steve Sandler. Oh my goodness.
Yeah.
And he'll be on a panel with Istvan Novak and Heidi Barnes from Keysight. We really have an all-star team.
Yep.
And I hope to get as many of them on the podcast as possible. So Altium Live, PCB West, PCEA. That's what you need to go do right now. So Rick, thanks for coming on. Thanks for sharing all your knowledge and wisdom. It's always a joy to have you.
Thank you. It's good to see you.
Good to see you too, Rick.
Take care.
For our listeners, thanks so much for joining today. We hope this has been a great resource for you and encourage you to go sign up for Altium Live. We look forward to being with you next time. Please like, subscribe, and comment so we can always know what you want to learn about. So we'll see you next time. And till then, stay healthy, stay safe, and always remember to stay on track.